Warm greetings to all. Today, we are going to discuss about the subject of analog and digital communication. In this subject, in Unit 1, we are going to discuss about what are the different types of modulation and what are the different generation methods of AM waves and different modulation schemes and how we are going to generate the different modulation and reduction process. First of all, we have to know what is communication system. Communication means it is a basic process of exchanging the information from one location to the another location. So we can say that we are going to be transfer the information from one point to the another point. That is, we can say it as flow of information. So this is the general block diagram representation of your basic communication system. The basic elements which is present here is the main thing is we needed the source, and next we required the transmitter, and without the channel we can't able to transmit the information. So at the destination point we needed the receiving part. So these are the basic elements of your communication system. So the information source can be maybe a different types of information sources. It can be either text messages or videos or any audio signals, like this different kinds of sources it can be transmitted. In the transmitting section, we are going to be convert your audio signal to an electrical signals which can be transmitted, and here we are going to perform some encoding process we are going to be done, and encoding and decoding process is to be done, which will be converted your audio signal to an electrical signals, so which will be transmitted through a channel media, and from that it can be received by the receiving section, which will be converting your receiving the information what you have been transmitted, and which can be recovered by your destination point. So while transmitting to the channel, there will be having some noises can be added. So the channel can be classified here as two main categories. So that we can say it as guided media or unguided media. So guided media means we can say it as any cables or wires which can be used to transmit the informations. Unguided media means we can say it as a very good example as air. So it can be called it as a free space. How we are going to be communicated through the air without any media, without any wires. So that is we can say it as guided medium or unguided media. So in communication system, the modulation is very important term we have to know. So it is a process of varying the characteristic of high frequency carrier signal is going to be changes in accordance with the values of the modulating signal. So in other words, we can also mention that it is a frequency translation technique. We are going to convert a low frequency signal to an high frequency signal. So mostly this modulation process will be carried over at the transmitting section, and demodulation process will be done at the receiving section. So modulation is very important thing which is to be done in the communication system. It is a process of modifying a carrier signal according to your modulating signal. So the resultant signal after the modulation, we can call it as modulated signal. So there are two different types of modulations out there. First one we can say it as it is analog modulation, and second one is pulse modulation. Analog modulation means we are going to be transfer a low frequency signal over this bandpass signal. So pulse modulation means here we are going to be considering a distal bit signal is going to be considered as a carrier signal. It can be a periodic train of pulses. We can say that it is amplitude and width and position is going to be changes according to the audio signal. So there is two types of modulation, analog and pulse modulation. So the main purpose of modulation process in a communication system is we can say it as we can able to have a good efficient transmission is possible, and we can improvise your transmission speed and distance, so that we can able to cover a long distance of communication with a shorter time. So here because of high frequency of the signals, there will be having less prone to noise and interference. So this is the main purpose of going for modulation. In overall view, we can say it as what is the main specific reason for going for a modulation here. We can mention here as we can able to obtain a reduction in height of antennas. Antennas plays a very vital role in the communication of the transmitting and receiving section in the communication systems. So antenna is a very important requirement of the equipment which is needed in your communication system. So if your reduction in the height of the antenna is reduced, we can say it as the cost of the equipment also reduced. So as we are going to preferring a high frequency of the signal, since as we know that lambda is equal to c by f, so we can say it as the antenna of the that is height of the antenna can be reduced with respect to the frequency here. So the second one is it can able to obtain a narrow banding of the signal, multiplexing, and we can able to overcome your equipment limitations, and we can able to perform your modulation by using your frequency assignment. So this is a example I gave here, how we are going to relate your frequency with your antenna height here. So lambda is equal to c by as we know the height of the antenna is lambda by 2. So the lambda by 2 is equal to c by f. As we know lambda is equal to c by f. So lambda by 2 is equal to c by 2 f here. So if you're having small range of frequency, low frequency signal, antenna height to requirement is 150 kilometer. If you are increasing the frequency to 1 megahertz, the antenna height has been reduced here. It reduced to from kilometer to meter. So from that we are making a confirmation that if you're increasing your frequency, the antenna height has been reduced. So here we can say it is a narrow banding. We're not recovering a wide band of frequency spectrum or anything else. Here, since we are using a high frequency of the signals, we can able to obtain a this narrow banding of the signals, as well as we can able to obtain a multiplexing of the signals, as we are going to be to multiplex all the signals and we are going to be translate through a one common channel. We can able to perform a multiplexing process can be done by using a modulation process. And next we can able to overcome equipment limitation is if the equipment is not a well processed for the incoming frequency, we can able to convert your this incoming signal to an high frequency signal by performing a modulation process. So we can able to perform a frequency assignment so that we can able to use the signal for the different types of applications as our radio and TV applications, as we are going to assign different range of frequencies. So the next we are going to come across a different classification of modulation. So as we know, it is a broadly classified as continuous wave modulation and pulse modulation. In continuous wave modulation, we will be having amplitude, angle modulations. Under the category of amplitude modulation, we are going to classify it as double sideband suppressed carrier, single sideband suppressed carrier, and vestigial sideband suppressed carrier. In pulse modulation, we will be have, as we had discussed earlier, pulse analog modulation and pulse digital modulation. So in pulse analog modulation will be classified as pulse amplitude and pulse time modulation. The pulse time modulation is have the two categories of pulse width, pulse width modulation, or pulse division modulation, or pulse length modulation. So it can be mentioned in different names here. And next we'll be having second category as pulse position modulation. In pulse digital modulation, we'll be having as pulse code modulation, differential pulse code modulation, delta modulation. In angle modulation, we'll be having as frequency modulation and phase modulation. In frequency modulation, we'll be having the category of wideband frequency modulation and narrow band of frequency modulation. So now in this unit, we are going to discuss different types of modulation schemes here. We can discuss one by one. First of all, we have how to know what is amplitude modulation. So we have amplitude modulation means that is we can say it as we are here we are going to be the amplitude of the signal is going to be changed, that is the carrier signal amplitude is going to be changed with respect to your modulating signal. So here we are going to find what is the modulation index and how we are going to represent your upper sidebands and lower sidebands, how we are going to relate to your power relations, and how we are going to define the different terms of powers in AM signal. These are the things we are going to discuss here. So the first modulation process here, the process of changing the amplitude of the carrier signal in accordance with the instantaneous value of the modulating signal is known as amplitude modulation. So we are going to change the carrier signal amplitude with respect to your modulating signal. So here we are going to expose your carrier signal as Vc of t is equal to Vc sin omega of Ct. So as we know, what is Vc is amplitude of the carrier signal, and omega c is the angular frequency of the carrier signal, and Vmt is we are going to express in terms of the sinusoidal function as Vm sin omega mt here. As we know what is Vm and what is omega m is the angular frequency. After amplitude modulation, what happens here? The carrier signal is going to be changed. So the after modulated signal, what happens here? The carrier signal amplitude will be changes with respect to the modulating signal. It's going to be overlapping of that signal. So we are going to add this Vc plus Vm here. So since Vc plus we have Vm, as we know, Vm is equal to Vm sin omega t, and take Vc as common here, and we are going to express Vm by Vc and sin omega t. So next here we are going to express Vc into 1 plus Vm by Vc. We are going to express in term as modulation index as, which is expressed here as EMA. sine omega mt. So this is, we can call it as modulation index, or how much of depth of modulation it has been happened with respect to the modulating signal. That can be expressed as the change in the amplitude of the modulating signal to the change in the amplitude of the carrier signal, which can be expressed by the equation as ma here. So the instantaneous amplitude of the modulated signal, this is a carrier signal which has been changed. So how the amplitude of the carrier signal will be changed, that has been expressed by this equation. And here we are going to change the amplitude, how the modulated signal has been changed after the carrier signal amplitude has been changes. So the changes can be expressed as VAM sine omega CT here. So you have to substitute that equation here, and instead of this VAM, you have to replace that particular equation here. After substitution, we'll be getting this equation in terms of sine VC sine omega CT plus VC sine MA sine omega MT sine omega CT. So now we are going to bring some trigonometric formula of sine A sine B, which is equal to cos of A minus B minus cos of A plus B divided by 2 equation. By replacing this term, we are getting the final amplitude modulated signal in terms of carrier, lower sideband and upper sidebands. So the lower sidebands here can be expressed in terms of omega c minus omega m, and upper sideband we can be expressed as omega c plus omega m. So which will be having the amplitude of ma Vc by 2 here. So this is a time domain representation of the AM signal. The first axis is message signal, and second one is carrier signal, and third one which is represented in time domain. So how the amplitude of the carrier signal has been changes with respect to your message signal. So this is your frequency domain representation of the AM signal, how we are going to express the amplitude of the carrier, lower sideband and upper sideband. As we are discussed in the equation, we have got the term for lower sideband as omega c minus omega m, and for upper sideband as omega c plus omega m, and the central carrier frequency, which will be having the frequency as center frequency as omega c. So here we are going to express one another term as bandwidth. The bandwidth is going to be a difference of lower sideband to the upper sideband. So this is your phasor representation of the AM. How we are going to express the resultant signal as well as the upper sideband as well as the lower sideband here. So which will be having the center frequency of carrier frequency signal. So here having VC, and in this the top arrow will be indicates your upper sideband and lower arrow will be indicates your lower sideband. The resultant signal will be added at the VAM of T. So which can be expressed as omega m and minus omega m. So which has the amplitude of ma Vc by 2. So next, as we discussed earlier, what is the modulation index here? M is equal to Vm by Vc. So what is going to be indicates how it will be indicates that the carrier signal is modulated. So it's going to be give the expression of the amount of power in the sidebands. So usually the value of modulation level will be ranges in the value of 0 to 1. So while if we have the value of modulation index as 1, we can indicates that it is a full modulation process. If the modulation index is greater than 1, we can mention that it is a distorted signal has been obtained there. So this is a modulation index we are going to define here in terms of Vmax and Vminimum. So we are going to define what is your Vmax and Vminimum. Based on that, we are going to find your modulation index. As we know that Vmax means it is a range of voltage level from the maximum to the center, maximum to the center of the origin here, this axis line. So we can define here Vmax means Vmax of peak to peak point means it will be top to bottom, and Vminimum means will be having the center frequency. So from that we can able to find your modulation index as Vmax minus Vminimum divided by Vmax plus Vminimum. So here we have 3 degrees of modulation index is possible. So modulation index has been categorized based on the modulation index value. If the modulation index value is greater than 1, we can say it is a over modulation. If it is lesser than 1, it is under modulation. If it is equal to 1, it is critical modulation. So in the graph which will be represented here, the first diagram indicates your under modulation, which shows the representation of the value as m is lesser than 1 here. And second one is critical modulation, how the phase reversal will be appearing in the critical modulation if the modulation index is equal to 1. And next, overlapping, that is for in over modulation, the value of modulation index is greater than 1. So we are going to get the overlapping of the signal will be possible in your over modulation. So in communication system, generally mostly we will be preferring the under modulation and critical modulation. The over modulation will not be considered, as we have some overlapping of the crosstalks and distortions will be possible. So this is the power relations in an AM wave, how we are going to relate your power in an amplitude modulation. So as we know that a total power will be equivalent to power component plus LSB plus USB.